I've been a professional lighting designer for almost 20 years. I love light and I love what I do. Colour is an integral part of what we do. And if you've ever taken a colour and put it in front of an LED fitting, you'll know that it looks completely different. And the problem is even worse when you've got both LED and tungsten fittings on the rig at the same time. So how do you fix that? Well, you can fix it through a process of trial and error. You can try different filters to try and match to get the colour you're expecting. But it would be so much easier if someone else could do the hard work for us. Thankfully, the team at Lee have done just that. They have launched a new range of filters specifically colour matched for cool white LED lighting. A range of popular colours are now available as Lee LED filters. Try to think of them as being colour corrected as opposed to colour temperature corrected. Let's begin with two light sources without any filters at all. On the left-hand side, you have the tungsten source of 3200K, and on the right-hand side, you have the cool white LED. So we're going to start by adding a piece of Lee 117 steel blue into our tungsten source. Now, if we add the same piece of 117 into the LED source, you'll see the difference. As you can see, we have two completely different colours from exactly the same filter. And now here comes the clever stuff. So we've taken the 117 out of the LED, and we're now going to add in the Lee LED 117. As you can see, we now have a more accurate visual colour match between the two sources. Here we've added Lee 158 deep orange into our tungsten source. Now, by adding Lee LED 158 into the LED, again, we have a good visual colour match. Now let's have a look at a piece of Lee 126 mauve. And if we take the same piece of 126 and apply it to the LED fitting, you'll see we have two completely different colours. Now we use Lee LED 126, and again we have a really good visual colour match. So how different are these colours really? Well, let's start with a piece of standard 117. And if you compare that to the Lee LED 117, you can see the colours are quite different. Let's do the same thing with 126. There's the ordinary 126, and there's the Lee LED 126, a completely different colour indeed. It's brilliant. Lee have done all the hard work, so we lighting designers don't have to. But how well do these filters work on skin tones? Well, we'll start off by lighting someone in the traditional tungsten light. Then let's crossfade to the cool white LED source. Now we'll add the tungsten back in, so we're using both sources together. I'm going to use Lee 117 steel blue and add that into the tungsten light source. And now, using Lee LED 117, we're going to add that in, and as you can see, we have a very good visual colour match. Now here is the science part. Let's take a look at some white light as plotted with the spectrometer. Here is the curve of a tungsten lamp with a colour temperature of 3200. Next to that, we can plot the curve of a discharge lamp with a colour temperature of 5800. Now take a look at the spectral curve of a cool white LED source. As you can see, there are some big spikes and dips, and some colours just aren't there. The Lee LED range has been specifically designed to manipulate the LED spectrum, giving you a visual match to the original colours, as well as reducing the blue spike that can be uncomfortable to look at. Lee LED. Clever stuff.